Okay, so today we are going to try and solve this problem on LeetCode, word search 2. So what does this problem want us to do? It basically says there's a 2D board given, and we are also given a list of words, and we need to find all the words that exist in this board. So how might we go about doing this? Can letters be repeated? It says the same letter cell may not be used more than once. Okay. And we can pick words, or rather letters, that are horizontally or vertically adjacent. Okay, so first things first, let's just get our the directions for our neighbors represented as an array. So that would be arrays. One going from left to right and one going from top to bottom. Okay, and now we can just start at every we can just start doing bfs at every element and or a dfs and see if we hit any of the words in the word list. To make this more efficient, we could create a try out of the words in the word list in the dictionary. All inputs consist of lowercase characters and the value of words are distinct. So I'm just going to go with a slightly more inefficient solution. So basically do a DFS from every position in the starting in the array and see how many words we are able to reach. Okay, and we return the list of words that we are able to find. So just to make things a little more optimal, I'll store the largest word length in the dictionary. So let's start there. Int largest word length equals 0. Then we iterate over words. This is like a small optimization. The try is, if we created a try, that would be optimizing this further. But I'm going to see if this optimization is enough to get this to pass. So we want to see if the current word's length is greater than largest word length. And if it is, then we set largest word length to s.length. We could also just use the math.max function. Sorry. So we compare both and we take the maximum. And we need a visited array. So it should be, I'm going to put the DFS in a separate method and implement it recursively. So let's create a visited array. Boolean should be fine. And set it to be the size of the board's length, and each row should hold as many columns as there are in the first column of board. So that's a good time to ensure we return an empty list if there are no rows in the board. And now we can go over the whole board. And we do a DFS. Wondered, have they given limits for how big the board might be? They haven't, so we may not know if this passes until we execute this. And maybe just keep a global answer array. And also a set for the dictionary. We can initialize here, and we can add the words to the dictionary here. So we need to move these out. It should also probably be private. Okay, and we need to initialize answer as well. And we just return answer here. You also need to clear reinitialize visited before each DFS. Starting to think a try may also not be optimal enough, but we shall see. So why DFS? I'm going to use x and y as parameter names for our current location. So if x is, we also need the board to be available. Maybe I'll just pass that in. Char 2D char array, solid B. So if x is less than 0 or y less than 0 or b dot length is greater than equal to x, or b of 0 dot length is greater than equal to y, or we have visited y, return else we loop through the directions and we recurse. So get the new x and y values. And then recurse. And you also need to know the current word. So thinking we could use a string builder, but does that really solve our problem, since we would need to basically convert it to a string when we compare? Yeah, I'm beginning to feel like a try is what is needed, and that's why it's marked hard. But let's start off with just a string, and then once it fails, we can work on making it use a try. So s plus xy if, so we need to like that here. Yes, then add it to answer. And we just return at the end. We need to mark this node as visited. And I think that should work. So let's see if it runs this basic example. There is an error, a typo. Let's run it again. Okay, we didn't get the output we expected. Let's see what I'm doing wrong here. Let me just print it. We can see what strings we're getting. Okay, there should be nx and ny. Still nothing. Oh, so this should be the other way around. Okay. So we need to add these checks here as well. And this should say nx and ny. Okay. So we got a wrong answer, but looks like felt like we should at least be getting words into the dictionary or into answer. So let's see, we get E. So why do we start at E? Okay. So this should contain more. Okay. Now I don't expect it to pass the submission, but it should pass the sample test. OEI. Okay. I know why. We need to false before returning. Okay. Looks like it passed the basic tests. 1189 lines. So let's pass in a bigger input array. And let's make this password really big. And we can see how many more operations we do. So we were at 1,189. You can see it's grown to 267,000 operations. So it's pretty easy to see that if we double the size of this array, you'll probably get a time limit exceeded error. Yep. So now how do we speed this up? You can see 194,000 calls to the DFS function. So one way to speed this up would be to create a try, and then as we go through as we traverse the 2D matrix using DFS, we wouldn't need to create the string each time. So let's see. I feel like we might be able to optimize it without that. Okay, so let's do the try approach. So create a private class representing the try, and each try is going to be basically an array pointing to try for the next letter, and let's say boolean for whether this is the end of the word. So actually we can just initialize next letter to new try as 26 positions and end of word to false, and now need to define method to add a word to the try. So the way we can do that is we basically set next letter of caret 0 to be a new try. We need to check if this exists. So check this, and also if stub is empty, then let's just set end of word to true and return end of word. We know a word ends here. If not, we check if next letter at 0. We need to subtract 26 from this. But we need to subtract the letter A. It's fine to just subtract the lowercase letter since the question tells us that only lowercase letters exist. So if this is not equal to null, then we initialize it. Else we just said so first we need to actually initialize pointer to this, and so if current end of word and current next letter refer to this next letter, but just be more precise. Okay, so now we need to change the pointer. We need to go into oh, so I'm going to extract this. So easy to replace, and so that we don't forget to subtract the letter A anywhere. So R equals current letter of index. So let's actually change this to a loop. So while this is not empty, we do all this and then loop. So while this is not empty, we get the character at I. And if that is, if I at that position doesn't exist, create it and move to that position. If it does exist, we just move to that position anyway. And so let's see what happens. If there's no characters, then we would basically set end of word to true. If there's one character, we would move to that try. They should say, and then we would exit and set end of word equals to true. So okay, so let's do that. So now instead of adding it to the dictionary set, we just add it to the dictionary try. Okay. And so instead of passing board of IJ, we can just say if dictionary try dot next letter of board of IJ minus A is not equal to null. Let's do a defense here. And we pass this in instead. So we'll change this type to be try T, and we'll say if T dot end of word answer that. Okay. So how do we ensure that we get all the words that are present? You can just have another string that says word. Okay, so I just realized this should be while less than s dot length, and we can set word current word equals s. Okay. So now we can get the word from the try. And all of this is fine if s dot length is greater than largest word length. Okay, that's not really needed anymore. So we get rid of that. Okay, we go through the array and we need to change this. What we need to do is we need to add another check saying if key dot next letter of pfnx and y. And this should be set to this. Okay. This looks like it might run better. I'm just gonna add that so we can see how many more operations it takes. So this was 190,000, 195,000 almost. Let's run this and see. Okay, so this should say add word. I got a little confused because of the sets add method. Okay, a null pointer exception in add word. Okay. Okay. Oh, sorry. So this should say if it's equal to null. Okay. I thought it said accepted for the overall answer. I was quite happy. Okay, you can see much fewer operations. I feel much better about this code. Let's just use one long string that actually has a prefix in the grid. Okay. Let's see how long that takes. Okay. Still not too bad. And I'm going to try and see what happens when I add something that doesn't exist. Okay. Just to confirm, I want to make sure that this shows up in the output. Oh, it's not. Okay, so I must have screwed something up there. Is the test case fine? Looks like the test case is fine because it passed. So my input must not be right. Seems okay to me, to be honest. I wonder why it's not expecting that in the output. Let me use a shorter string. Maybe there's a typo that I just missed. Okay, it's showing up now. So there's probably a typo in this part of the string. So you're here at this A, and there's an AZED. Yep, and then an IHKRR, AANY, and then then IFLB QAA. Yeah, looks to me like that should show up. Do I not have enough elements in each? Just doing a quick compare. Okay, so those are the same size. All of them seem to be the same size. That's really odd. Okay, that shows up too, so maybe something here. It just didn't pick up the just didn't pick it up maybe. Oh, okay, I see what's happening. So after this y we are at the end of the array. Yep. So instead of IFL, it should say YNAAQLFI to start off with, and that should show up. And now we should maybe see some more operations. But yeah, it still fits. Yep. And it's showing up in the output. And if I change that to an A, there should be no result. Yep, that's missing. So that's great. That's missing as we expect. So I kind of want to submit this, but I think the DFS may not be the best. Maybe I want to do a BFS. So let me think about that for a second. If I do a BFS, I would look at these and I would only go further if it exists. But it's kind of the same with the DFS because I have the try. So the try stops it from going down paths it shouldn't. Okay, it might work. I'm going to try and... should I be removing something? Maybe I can remove the dictionary. Doesn't look like that's needed. Not too happy about having answer as a global variable, but it'll have to do. We shouldn't be returning here. It's important to note because this might be a prefix of a longer word. So let's say we had this as well. Okay. We should get both the prefix and the word in the output. Oh, we are not. Why is that? It's not expecting it either. Oh, sorry, we are. We're just not getting this. So let me change this back to a word that should be in the output. Okay, and we are getting both. So looks like this should work. I hope I've not missed out any corner cases. I'm wondering whether we need the visited array. Yeah, I think we need it. We definitely need it to basically avoid going in circles, but I don't think we need to reinitialize it since we're setting it to false here. Yeah, okay, let's sum this. And I hope it passes. Okay, it's failed. Okay, let's see what's good about this input. Okay, so the input is 2 A's and it's expecting an A. Okay, so I see the issue. We're basically returning duplicates. So by changing I need to change the initialization. So if I change that, hopefully it works. I think it should. Okay, that's fixed that. So I'm basically now using a set, and then I converted it into an array before returning it. Oh, okay. It's a trivial error. Actually, wait. So how is this getting added? We should be setting this to visited. Oh, my bad. If it's visited, so we start here, we move to this A, and then we move back to this. And at that point, this is visited, so the check should be before. And I think that way we'll even be able to clean this up. So I don't think we can just pass in. Give me a second there. So yeah, I think we can just do t equals t dot next letter. Okay. And null we return, because we know it's not a word. So we don't need to actually change t there. We don't need to change dictionary try here either. We can get rid of this if statement, which is pretty cool, making it a lot neater. Okay, and we don't need to check this either. That's pretty nice. And we don't need to check this either. So I guess that's the advantage of writing like clean code. I think it looks good. What happens if we complete a word and then we go out of the array? Okay, that might be a problem. Okay. Okay, 1 second here. So we actually don't need to worry about x and y here. We just need to worry about visited. We can look for x and y here. So the reason being, if we have let's say matrix like a comma a, we would basically do look at a, then look at this a, and then we would be out of bounds of the matrix. So this would actually return true, and we would have returned even though we want to hit this point. So now we'll basically adding back what we removed earlier. I'm going to check if we are hitting out of bounds before we recurse. Well, that work, would it have worked without moving it here? So let's say initially we start at 0 0, But we haven't gone to 0, 0 yet. And then we go to 0, 0 here basically. And if it's valid, then we would go here and then we'd iterate and go to 0, 1. And then 0, from 0, 1 we'd go to 0, 2. And from 0, 2 we'd go out of bounds to 0, 3 for a matrix that was A, comma A. So now we are at 0, 3, but at 0, 2 we should have already added it. So it might be fine to just have had it there. Okay, that works. Let's test with our full output. Okay, that works too. Let's test it out with the other. Let's guess that failed. Okay, that's promising. Great. So it worked. So I hope this helped you guys understand how to use a try and how to solve our LeetCode question.